The Alborz Mountains are located in northern Iran. They were formed in the same process that created the entire alpine Himalayan mountain chain. Let's have a look at the spectacular geology of the Alborz Mountains. The Alborz Mountains are located in the northern part of Iran. These beautiful snow-capped mountains extend from Azerbaijan and Armenia in the northwest to Turkmenistan and Afghanistan in the east. The mountains are just south of the Caspian Sea, and their formation is the result of the closure of the Paleotethys Ocean and the collision between Eurasia and the microcontinents that now form central Iran.
رشته کوههای البرز که در شمال ایران قرار گرفتن جزئی از چین‌خوردگی آلپ هیمالیا محسوب میشن. این رشته کوه رسوباتی بودن که در دریای تتیس که در فاصله بین ورقه اوراسیا و گوندوانا قرار گرفته بودند که بعداً با باز و بسته شدن متوالی چند باره دریای تتیس تونستن رسوباتی رو در اینجا چین بدن و کوههای البرز رو بسازن.
One of the most interesting points about the Alborz Mountains is the fact that you can see in the outcrops rock formations ranging in age from the Precambrian up to the present time. In addition, there are several prominent faults along the length of Alborz. Most of these are strike, slip, and thrust faults. A cross-section through the Alborz Mountains reveals the deep structure. Tehran is at the right-hand side of this cross-section. There are numerous low-angle faults that form what is called a flower structure. Some of these faults pose a serious seismic hazard to Tehran, such as the Moshe Fasham fault.
So there are several faults around Tehran. There are 5 major ones. Probably the most important one is the one to the north, which is called North Tehran Fault. There is a second one also to the northeast of Tehran. It's called Mushan Fault. There are several to the south. The Ray Fault, which consisted of South Ray and North Ray Fault, south part of the Tehran. There is also a Kahrizak Fault in the southern part of Tehran. And lastly, there is Ayvanak Fault, which is to the southeast part of Tehran. Tehran has an active set of faults surrounding it, so maybe every 150 to 200 years there is an active earthquake. The last perhaps major earthquake that happened in the region was around 1830, which was a magnitude 7 on most likely one of the north faults, Mushan Fault in Tehran.
زیادی که داشته دارای گسله‌های فراوانیه. الان ما اینجا گسل موشا فشم هست که یکی از گسل‌های خطرناک البرزه که این قشنگ در اینجا افتادگی گسل کاملا قابل مشاهده است.
In this section you can see a normal fault that occurs in some Jurassic age sediments. There's also a very clear contact between these sediments and the basalts of the Damavand above them. After the closure of the Tethys Ocean and the formation of the Alborz, there was heavy rainfall in the mountains which caused a great deal of erosion. The result was the formation of thick alluvial deposits on the southern boundary. Tehran is located on the most recent alluvial deposits called Series A sediments, or Hazar-Dareh.
If you think about it, the southern part of Tehran is acting like a jelly bowl, and when earthquake happens, the ground motion amplifies and would increase the damage to the vulnerable infrastructure that exists in Tehran. Civil engineers are in front line of bringing the public safety to the communities. It starts by engineers and civil engineers understanding earthquakes and the effect of earthquakes on buildings, and it continues by them being able to implement all those lessons and practices into their designs and implementation. The projects that civil engineers do are not only for sheltering people, but also for protecting their lives and providing a safe environment at the event of major disasters.
Geologists have succeeded in determining the main structural features and the geological history of the Alborz Mountains. The uplift of these mountains has led to the deposition of a thick section of sediments upon which the city of Tehran is built, and field studies have identified several active faults near Tehran. Seismic monitoring shows that the southern boundary of the Alborz Mountains and the region around Tehran is seismically active. That's why earthquake engineering is so important. Knowing that active faults are present, civil engineers can apply earthquake-resistant building codes that will minimize the likelihood of building collapse, even in the case of a strong earthquake. This is a great example of cooperation among geologists, seismologists, and engineers.